I am the Philosophical Bachelor, and today I want to talk about a quantum field metaphysics of emergence. According to Richard Campbell, emergence is a mystery because it is analysed through the paradigm of substance metaphysics. If process metaphysics is instead adopted, emergence can make sense. Emergentism posits that novel properties can arise at a system level, and these properties are irreducible to the properties of its parts. In the Metaphysics of Emergence published in 2015, Campbell seeks to explain how emergence is even possible given the nature of reality. Thus, he must first examine the nature of reality. Substance metaphysics places a primacy on physical entities, be it macroscopic objects such as tables and planets, or microscopic ones, such as atoms, molecules, and even the fundamental particles such as quarks, photons, and electrons. Substance metaphysics has been the dominant paradigm since Aristotle, who conceived that entities are made of form or morpher, plus prime matter or hyla. This is known as hylomorphism. Plato, Aristotle's teacher, was less certain as he was conflicted between two competing theories proposed by the pre-Socratics. Heraclitus posited that all is in flux, that everything is changing, while Parmenides posited that all is static, that the world is one fixed, eternal, unchanging, monolithic thing. The problem that Parmenides and later Plato grappled with was how we can possibly have any knowledge of things if they kept changing. To use the language of Aristotle, how can we know in a changing entity what is essential and what is accidental to it? Plato thus conceived of two realms in his theory of forms. The first, an intelligible realm of unchanging forms, where the pure essence of an entity resides. This is not the world we live in, but a realm beyond our sensible world. It is our encounter with these forms in this intelligible realm prior to our births, in the sensible world, that is the basis of our knowledge. When we encounter the imperfect instantiations of these forms in the sensible world, we are reminded of and recall the forms we had earlier encountered, and hence know what is essential and what is accidental to each thing. The form is what is essential and the rest is accidental. Hence, Plato adopts Parmenides' concept of fixed, unchanging eternal entities for the intelligible realm, while he adopts Heraclitus' concept of flux in the sensible world. For Plato, what are more real are the intelligible realm and its forms. Aristotle took Plato's idea of forms and instantiated them not in an intelligible realm, but in every sensible entity which is formed when form enters matter. He brought Plato's eternal transcendent forms down to earth, and in that way got rid of the intelligible realm and its forms. Substance metaphysics was hence entrenched to the detriment of process metaphysics since 2,400 years ago. The phenomena of change then became a major difficulty, since if an entity is characterized by its form or essence, how can it possibly change, and where does change come from since it is not part of the essence of anything? In any case, our metaphysical understanding could have gone the other way, where Plato and Aristotle could have recognized the primacy of process or flux, and then shifted their metaphysical emphasis towards change or the accidental. The phenomena of permanence would then have become the major difficulty, since if process, flux, or change is what is fundamental, how can they account for what seems to be stable and lasting entities? Nonetheless, substance metaphysics was and still remains the dominant paradigm in philosophy as well as the sciences, though in the last century, the advent of quantum theory and relativity versus Newtonian mechanics has undermined this worldview. Quantum wave-particle duality has shown us that what we have understood to be concrete physical entities sometimes behave as waves of energy. In addition, special relativity demonstrated the convertibility between matter and energy. Later, quantum field theory extended quantum mechanics, incorporating special relativity into quantum mechanics and proposing that fields, which are definitely not substances, are pervasive, giving rise to all physical phenomena. The concreteness of physical entities now seems not so concrete after all. If proponents of process metaphysics like Campbell had their way, we will not be talking about particles at all. There will not be wave-particle dualities or matter-energy conversions, but only more or less stable processes, with more stable processes giving a semblance of permanence which translates to what we presently call entities. Campbell's theory of emergence relies on an acceptance of process metaphysics. He argues at length for the merits of a process versus a substance view. I shall not, but some examples can help make clear why process metaphysics is more encompassing. A cup is a familiar concrete physical entity, but how about a river? What makes a river what it is its flowing waters. The banks of a river are static, but they are not the river. If the waters of a river do not flow, it is not a river but perhaps a lake or a pond. The flow of a river's waters is essential to the concept of a river. So the ideas of flow and process are not alien even to a layperson. Substance metaphysics rarefies this flow into an entity called river. But if we try to grasp the concept of river as a fixed entity the way we can grasp the concept of cup, we will miss what makes a river a river. We will miss what is essential about the river. We also commonly view living things, as the term implies, as things, as fixed entities. A human being is conceived as a person with a clear and distinct identity. But we know that every single cell in that person's body except the eyes will be different after some years. If we stick to substance metaphysics, should that person then really be considered the same person? As I had already mentioned, substance metaphysics struggles to explain change. Process metaphysics is adept at explaining change, but struggles to explain permanence. Why then should we accept process metaphysics, since substance metaphysics is dominant and seems to have served humanity so well? Firstly, it is because it has problems, but then so does process metaphysics. Secondly, it is because the best science today points us in the direction of process, this science being quantum theory. Quantum mechanics has two important concepts: Walter Heisenberg's uncertainty principle and Erwin Schrödinger's wave equation. Heisenberg tells us that there is a fundamental uncertainty in our knowledge of the physical variables of a particular quantum particle, such as its position and momentum, which we can think of as its velocity. The more certain we are of the position of a quantum particle, the less certain we are of its velocity. This is because the particle at times behaves like a particle and at times like a wave. This is known as wave-particle duality. The more certain we are about the particle's position, the more uncertain we will be about its velocity. Because of its wave-like properties, there is a range of possible velocities it is in, since this particle consists of multiple waves, each with their own velocity. The more certain we are about the particle's velocity, the more uncertain we will be about its position, because it could be anywhere along the wave of that velocity. When we lock down its position, we are trying to think of it as a particle, since only particles have position. But in that case, we have to contend with how, in one position, there is a superimposition of multiple waves, each with their own velocity. When we lock down its velocity, we are trying to think of it as a wave, velocity being proportional to frequency, which is a wave property. But in that case, we have to then wonder what it means to speak of a point position of a wave, since waves do not occupy just one point in space, the way particles do. Schrodinger's equation then can be used to calculate the probabilities of the parameters. We are able only to know how probable their values are. The certainty implicitly assumed by substance metaphysics is thus threatened. But since quantum mechanics speaks of a wave-particle duality and not just a monistic energy, is process metaphysics better? Enter quantum field theory, which extends quantum mechanics. Quantum fields resolve certain difficulties with quantum mechanics, which sometimes interprets quanta or packets of energy as analogues to particles. One of the difficulties confronting scientists since Isaac Newton is how forces transmit over a distance. For one body to exert a force on another, it would seem that they need to contact each other the way one billiard ball causes another to move by knocking into it. But when one body attracts another gravitationally, how does this force of attraction transmit without any contact? It is almost as if the force vanished and then reappeared at the other body to be felt by it, but this cannot be, since energy would then not be conserved in the interim. It also seems to make this transmission instantly, but that also cannot be, since special relativity already tells us that nothing can travel faster than the speed of light, including gravitational forces. Fields overcome these difficulties by being the medium through which forces and energy can travel. The gravitational waves propagate through the gravitational field, taking some time to reach other bodies. Fields are pervasive. There is the gravitational field, but also electromagnetic field, and each quantum particle also has its own quantum field. For instance, an electron field surrounding an electron or a proton field surrounding a proton. When these fields interact, excitations arise at certain places in the field, which are quanta or packets of energy caused by the superposition of the fields. We have come to refer to some of these quanta or packets of energy as particles, but more accurately, they are derived from the quantized excitation of fields, making fields more fundamental. In this paradigm, particles and physical entities are metaphors, useful fictions of what in reality are quanta or packets of energy arising from field interactions. Everything is ultimately composed of quantum fields of various scales and complexity, writes Campbell. By everything, Campbell means every physical thing from the micro to the macro scale, from quarks to planets. This requires us to consider the relations between fields as the source of the properties of all entities. Some thinkers have argued that quantum theory is just a mathematical construct, a convenient theoretical method that does not translate to reality, but there is physical evidence at both the micro and macro scale for it. When two reflective and uncharged plates are placed very close to each other in a vacuum, there is a resultant net force pushing the plates together. This is the Casimir effect, which demonstrates the existence of virtual particles. Virtual particles are a consequence of quantum field theory, where the field's fluctuations and interactions in a vacuum generate virtual particle pairs, a particle and an antiparticle, that usually annihilates very soon after. In quantum field theory, a vacuum is not completely devoid of everything. There are still fields in it, and as a consequence of Heisenberg's uncertainty principle, field fluctuations leading to virtual particles. There are fields in it because quantum fields are a fundamental property of space itself. In the Casimir experiment, there will be more virtual particles generated outside the plates than between them simply because there is less space between the plates, leading to less virtual particles there. Some of these particles will collide with the plates. Since there is more space and hence more virtual particles outside the plates than between them, there are more collisions from outside the plates, resulting in a net force pushing the plates towards each other. As for macro phenomena, superconductivity and quantum computers rely on quantum theory. Quantum theory is considered one of the most successful theories of physics, as it is well tested and gives precise results that agree with experiments. For our purposes, quantum theory, specifically quantum field theory, gives us a way to move away from a particle and physical entity paradigm to a process paradigm, where what exists ontologically are fields and their interactions, that is, processes. Campbell writes, "The development of physics since the beginning of the 20th century has provided explanations of how quantum fields are organized in various ways so as to yield the different kinds of elements ordered in the periodic table. Fields and their organization can account for each of the various elements and their chemical reactions using quantum chemistry and its associated molecular orbital theory. We do not need to appeal to particles and entities to explain physics and chemistry. Since fields are more fundamental, we can do away with particles and entities altogether." There are two further consequences, the first being the old canard of how science is deterministic with its implications for free will. Heisenberg's uncertainty principle definitively tells us that uncertainty in physical variables is an ontological characteristic of the stuff in the universe. It is not merely that we do not know or are unable so far to technically calculate the variables presently, but may in future do so when we gain more knowledge or develop better methods. This uncertainty is an outcome from wave-particle duality, which means it is a characteristic of reality itself. Pierre-Simon Laplace proposed in 1814 that a super-intellect can compute the future if it knew the physical variables of all the atoms in the universe at any instant in the past. This idea that all is determined and hence is computable came to be known as Laplace's demon, but this demon has been laid to rest with Heisenberg's uncertainty principle. The deterministic calculation it posits is in principle impossible even with a super-intellect or a supercomputer, because we cannot know all physical parameters with certainty. If we knew the momentum of an atom, we cannot know its position, and vice versa. The second consequence is more to the point of Campbell's book. Emergence can result from the organization of fields. I had, at the beginning of this essay, provided a definition of emergence, and it centers on irreducibility. In a process view of emergence, the question of reducibility evaporates. The idea of reducibility is that the properties of parts at a lower level flow upwards to the system level and in that way cause system level effects. For instance, it would be the activity of neurons that causes thought. Reduction can keep going until we find explanations from the most basic level, presumably the level of fundamental particles. The field view throws the conception that there is any most basic level into doubt. Fields are unlike particles and entities. They are a continuum where their relation to one another is what causes the macro phenomena. The idea of levels does not apply. We should not think of quantized excitations as proxies for subatomic particles because they are part of field interactions, which then depend on the relation between fields. They are processual. However, Campbell notes that not all questions of physics have been settled, and there are still conceptual conflicts between the various contemporary scientific theories, so the way we understand quantum theory today may be superseded. In fact, they most likely will be, since dominant and accepted scientific theories of the past have been superseded. This is known as pessimistic meta-induction in the philosophy of science. Nevertheless, Campbell suggests that even if our current and most plausible theories are superseded, the new theories still have to explain the evidence. He writes, "If those theories are strongly confirmed, any theory which supersedes them will also have to provide explanations of the evidence which confirms the theory they supersede. And if the underlying contention of structural realism is right, the mathematical or structural content of current theories will be preserved in their future replacements. And that is enough to bestow credibility upon the metaphysical model I am advocating. Campbell has built his foundation for emergence on a process metaphysics which depends on quantum field theory. However, quantum field theory has yet to be completely worked out. He is trying to secure the future of his metaphysics of emergence, but refuses to allow it to be hostage to the evolution of science. He does have a point that whatever new surprises science has for us in the future, that it has to account for the evidence. However, evidence is theory-laden, as they say in the philosophy of science. The way evidence is understood or even expressed depends on the theories used to understand and express it. Campbell now moves on to the relation of process metaphysics to emergence. Emergence can happen because the properties a system have are due to how the system's component processes are interrelated. Organization characterizes the extent of the interrelations among the components of the system in terms of their number, scope, and dynamics. That is, the degree of non-linearity it exhibits, writes Campbell. Processes are not atomic but interact with other processes, both internal and external to its system, to sustain themselves. The relationships and their non-linear effects are the source of causation as opposed to the entities themselves in substance metaphysics. A functional organization is defined as an ordered configuration of processes which is able to do causal work, he adds. Processes exist only in some organization or other. It is how they are organized which generates their properties and powers. To distinguish between a system and its environment, a boundary needs to be defined. These boundaries can be impermeable, leading to a closed system like the surface of a ball, which keeps the air inside it in and what is outside it out. Or it can be porous like human skin, which allows moisture both in and out through it, leading to an open system. Campbell suggests two ways in which processes can organize one another so as to persist, meaning that their resultants are stable. The first are energy wells, where their processes are self-contained at the system level. The ball as a closed system is an example of an energy well, which is stable all by itself. These energy wells are in equilibrium and will persist and remain unchanged if left alone. The second are far from equilibrium systems. If left alone, because they are far from equilibrium, they will perish. Campbell's example is a candle flame. The flame requires the wax of the candle as fuel and oxygen from the air to support combustion. The heat it gives off creates convection currents to carry away the combustion product of carbon dioxide while bringing in fresh air to sustain the flame. It is an open system because it requires materials from the environment to keep going. Despite being far from equilibrium, it remains stable so long as the materials and processes such as the convection currents are available. It also requires conditions to be suitable for its persistence. The convection currents depends on the temperature difference between the flame and its surroundings. If the temperature of the surroundings increases too much, the convection currents will cease. Fresh air will not be able to reach the flame, and the carbon dioxide from combustion will not be removed, smothering the flame. The human body is another example of a far from equilibrium open system. If we could not take in oxygen and nutrition from the surroundings, and could not pass the waste products of our bodily processes into the surroundings, we will suffocate, starve, and be poisoned, respectively. We depend like the candle flame on taking in materials from the environment, disposing of waste into it, and on its conditions. Too high an ambient temperature and our bodies will overheat. Too low and we will freeze. Both the candle flame and the human body can maintain their stability if they can take in materials, remove waste, and have the right environmental conditions. They are not self-contained, but are self-maintaining through their interactions with their environments. However, for the candle flame, once the candle's wax is exhausted or the room is filled with too much carbon dioxide, the flame dies out. The flame is unable to actively seek out new wax or leave the room. The human being, however, is able to maintain its self-maintenance. When food has run out, we are able to go hunt for more or simply pop down to the market. If the air in the room becomes too stale, we are able to open a window. When it is too cold, we are able to put on more clothing. We are recursively self-maintenance. Campbell considers recursive self-maintenance as an emergent property. It is not in the properties of the parts of the human being, but of the whole or the system. The lungs are unable to open the window to let in fresh air. The stomach is unable to go hunt for food. It is the human being as a whole system that has the ability to do those tasks. Reflecting on Campbell's notion of emergence as organizations of processes, once we accept that process is the true ontology, all physical things can be considered to be emergent from quantum and gravitational fields, since all things are organizations of processes, including the quantized field excitations that constitute fundamental particles and the subsequent organization of those processes to obtain the processes that comprise larger scale entities. Emergence then would not be a mystery but a regular occurrence observed at all scales and explainable through process ontology. If we can reliably or predictably cause novel properties to emerge by directly manipulating fields, that will validate Campbell's Metaphysics of Emergence. However, a characteristic of emergence, if not in Campbell's understanding, at least elsewhere in the literature, is the inability to predict the emergence of such novel properties. If it was predictable, it is then reducible in the sense that it can be inferred or deduced from the scientific theories governing the parts of the system and hence is not considered emergent. However, that idea of reduction was based on an idea that the properties of the whole or system level are reducible to that of its parts. Campbell's emphasis is on the relations between the parts. By arranging the parts in new ways, novel properties may emerge. Arranging things in different ways to generate different functionality is nothing new. Wheels and shoes, when combined, create a whole new way of getting around and having fun. Fan blades, when mounted vertically, can be used in windmills to generate electricity, or as helicopter blades when mounted horizontally to generate aerodynamic lift. Same blade design, different function. These examples show how Campbell's insight that it is not just the part themselves that determine function, but how they are arranged, their relations, makes sense even if one does not accept process metaphysics or quantum field theory. Since the organization of processes is the cause of properties, by organizing processes differently, new properties may emerge. Does this mean that by arranging computers or computer chips together, either more of them or in different architectures or both, that we may one day have sentient machines? Nothing in Campbell's emergence theory prevents it. By understanding the phenomena of emergence, we can get some ideas on how to systematically generate emergence, such as deliberately creating non-linearity in the relations between the parts, fostering reflexive relationships between parts through feedback loops, introducing different parts into a system, and complexifying systems through adding in more parts and arranging them in different ways. These ways are unlike the linear scaling up of proven smaller scale systems, replicating successes but on a larger scale. Probably the most common way though is simply try and error. By trying different ways of doing things, we may be surprised by emergent phenomena. We have reason to be hopeful, but must also act cautiously, since emergent surprises can turn out to be good or bad. Thank you for listening to the Philosophical Bachelor.